Hi, this is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss some more numericals related to COP of refrigeration. So let's see the question number 1. What is the COP of a refrigeration system if the work input is 40 kJ per kg and work output is 80 kJ per kg and refrigeration effect produced is 130 kJ per kg of refrigerant flowing? So you can see in this problem, input work and output work, two works are given. So we will have to calculate the net work. Okay, so the net work will be 80 minus 40, that is 40 kilojoule per kg. Now we have to calculate the value of COP. So you know the COP of refrigerator is defined as refrigeration effect to the net work. Refrigeration effect is given as 130 kilojoule per kg and net work is 40 kilojoule per kg. So we will get the value of COP as 3.25. Now let's see the question number 2. Find the relative COP of a refrigeration system if the work input is 100 kilojoule per kg and refrigeration effect produced is 250 kilojoule per kg of refrigerant flowing. Also theoretical COP is 3. So we have to find out the relative COP. Now relative COP is given as the actual COP to the theoretical COP. Here theoretical COP is given as 3, so we will have to calculate the value of actual COP. Now actual COP of a refrigerator is given by refrigerating effect upon work. So we can find it out as 250 divided by 100. So it will be 2.5. Now since the actual COP is 2.5 and theoretical COP is 3, so we can find out the relative COP as COP relative equal to 2.5 divided by 3, that is 0.833. So this is how we will calculate the value of relative COP. Now let's see question number 3. Find the COP of a refrigeration system if the work input is 30 kJ per kg and refrigerating effect produced is 120 kJ per kg of refrigerant flowing. So we are given the work input as 30 kJ per kg and refrigerating effect as 120 kJ per kg. We know the formula for COP of refrigerator equal to Q2 upon W. So we can find it out as 120 divided by 30, that is 4. So in this way we will calculate the value of COP of this refrigerator. Now let's see very important question. Question number 4. A Carnot engine operates with a source at 500 Kelvin and sink at 375 Kelvin. If the heat engine takes 600 kilocalorie of heat in one cycle, what is the heat rejected to sink per cycle? So this question is not of refrigerator, it is of heat engine. Now as we know, in heat engine, heat is supplied to the engine, which is Q1, and the heat rejected is represented as Q2, which is rejected to the sink. Work is done by the system, so W equal to Q1 minus Q2. Now we know the efficiency of engine is W by Q1, net work upon heat supplied, and which is equal to 1 minus T2 by T1. So W by Q1 equal to 1 minus T2 by T1. So we can find out the value of W as W equal to Q into 1 minus T2 by T1. Q is given as 600. 1 minus T2 is 375 and T1 is 500. So we can get the value of work as 150 kilocalorie. Now we have to find out the value of heat rejected to the sink per cycle. That is, we have to find out the value of Q2. Now we know W equal to Q1 minus Q2. So Q2 will be equal to Q1 minus W, or Q2 equal to 600 minus 150, that is 450 kilocalorie. So in this way we will find out the value of heat rejected to the sink. Now one more question is there. A reversible engine has ideal thermal efficiency of 30%. Again, it is a reversible engine whose efficiency is given as 30%. We know efficiency equal to 1 minus T2 by T1, which is given as 30%. When it is used as refrigerating machine with all other conditions unchanged, what will be the COP of performance? So the question is that efficiency of an engine is given as 30%, and you have to calculate the value of COP of refrigerator for same working conditions or same working temperatures. Now we will apply the formula efficiency equal to 1 minus T2 by T1. So 0.3 equal to 1 minus T2 by T1. So we can find out the value of T2 by T1 as 0.7. Now if the temperature limits remains same, then COP is of refrigerator equal to T2 upon T1 minus T2. If we divide this T2 in denominator, then we will get 1 upon T1 by T2 minus 1, or 1 upon T1 by T2 is 1 upon 0.7, then minus 1. So by calculating this value, we will find the value of COP of refrigerator as 2.33. So in this way we can solve these type of numericals. Okay, thank you everyone.